You ever see one of those old-timey fire extinguishers maybe in an antique shop or a dusty corner of a warehouse and wonder what its story is? Well, some of those relics are hiding some seriously dangerous secrets. Let's dig in.
I mean, seriously, believe it or not, a device that looks just like this was once the absolute peak of fire protection technology. These things were literally everywhere, in our homes, our cars, and all over our workplaces.
But fast forward to today, using one isn't just a bad idea. It's strictly prohibited by major safety standards, from groups like OSHA and the NFPA. So what happened? How did a tool that was designed to save lives become a recognized hazard?
In this explainer, we're going to break down the fatal flaws of two of the most common obsolete extinguishers, the old soda acid type and the infamous carbon tetrachloride model. We're also going to see how safety science finally caught up, and, of course, what we use instead today.
Okay, first up, the soda acid extinguisher. This was patented in the US way back in 1881. For its time, it was a total revolution in fire safety, a real game changer.
Now, the genius behind this thing was a pretty simple but powerful chemical reaction. To use it, you'd literally have to flip the entire heavy canister upside down. When you did that, a little glass vial inside, filled with sulfuric acid, would break, and that acid would mix with a solution of sodium bicarbonate, baking soda, and water. That mix created a massive amount of CO2 gas, which instantly pressurized the tank and blasted the water out the hose.
For you science buffs, here's the actual reaction. You've got sulfuric acid plus sodium bicarbonate, and that gives you sodium sulfate, water, and of course that all-important CO2 gas. It was a really clever way to get pressure on demand without needing a heavy, pre-pressurized cylinder.
But, and this is a huge but, that clever chemistry had some very serious problems. For starters, the reaction was totally uncontrolled. Once you flipped it, the whole tank was going to empty, whether you wanted it to or not. Then there was the fact that the acidic solution was constantly eating away at the inside of the copper or brass shell, and if the hose or nozzle got clogged with debris, well now you've got all that pressure building up inside a corroded tank, essentially creating a bomb.
So, the very device that was supposed to save you from a fire could violently explode in your face. By 1969, the evidence was just overwhelming. Underwriters Laboratories, or UL, officially delisted all of these inverting-type extinguishers. Their time was done.
So if the soda acid extinguisher was basically a mechanical failure waiting to happen, our next device, the carbon tetrachloride extinguisher, well, this one was hiding a much darker chemical secret.
Carbon tetrachloride, or carbon tet, seemed like a miracle. It was a clear liquid that was amazing on flammable liquid and electrical fires. The kinds of fires where water just makes things worse. These small pump-action extinguishers got super popular, especially for cars and airplanes.
It worked, it was portable, it was versatile. So why is it now considered one of the most hazardous things ever put into a fire extinguisher? This is a classic question you might get in a safety officer interview, and the answer is absolutely chilling.
The very act of using it to put out a fire created a new, invisible, and deadly threat. See, when carbon tetrachloride gets heated up by a fire, its chemical structure breaks down, and it can create several toxic chemicals, but the absolute worst of them is phosgene gas.
And if that name rings a bell, it should. Phosgene wasn't just some nasty industrial chemical. It was a poison gas, a chemical weapon used in the trenches of World War I that was responsible for tens of thousands of deaths. So people were, without knowing it, deploying a chemical weapon agent in their own homes and workplaces.
But even without the phosgene, carbon tet itself is just nasty stuff. It is one of the most powerful liver toxins known to science. It also attacks your kidneys and your central nervous system. The EPA even calls it a probable human carcinogen. And here's a key detail for all you safety pros out there. If someone has been drinking alcohol, the toxic effects of carbon tet are dramatically worse.
So think about it. In a small, enclosed space, using one of these could expose you to a lethal poison gas and a powerful toxin. It really got to a point where the extinguisher could be a much bigger threat than the fire you were trying to fight.
The stories of these two extinguishers teach us such a critical lesson about how safety science has evolved. It's not just about finding what works, it's about finding what's safe.
And that brings us to what might be the single most important lesson from all of this. Just because something extinguishes fire doesn't mean it's safe. Early fire protection was obsessed with the first half of that sentence. Modern safety science is obsessed with the entire thing.
What's really wild is just how long it took for this to change.
You see the patents from 1881 and 1910, but it took until the 1950s for the science to catch up and for us to understand how truly toxic carbon-tet was. And it wasn't until 1969 that the soda acid models were finally pulled from the approved list. Today, of course, both are totally forbidden by modern standards like NFPA 10.
So what happened next? Well, the fall of these dangerous technologies really paved the way for the reliable, modern extinguishers that we all know and trust today. And the progress we've made is just night and day. We've gone from these chaotic chemical reactions to stable, pressurized agents. We replaced things that produce toxic byproducts with clean, non-toxic agents. We swapped out containers that could explode for reliable, engineered cylinders. And we developed multi-class extinguishers that are just so much more versatile.
The bottom line is this: the whole field of modern fire protection is built on the very hard lessons we learned from these early and often very dangerous mistakes.
So why does all this history matter to you right now? Because these old units still pop up in older buildings, warehouses, and barns. If you see one, here's your action plan. First, recognize the risk immediately. Second, do not handle it, and whatever you do, do not try to use it. Third, report it to a safety officer or your manager. And finally, make sure it gets scheduled for safe, professional removal. This isn't a DIY project.
And this whole history is a critical reminder for all of us to stay vigilant. It forces us to ask that really important question: what other legacy hazards, outdated equipment, old chemicals, forgotten procedures might still be hiding in our own workplaces?
If this explainer helped you understand why we use the equipment we do today, please do us a favor and like and share it with your team. And for more deep dives into the science and history of safety, make sure you're subscribed. Stay safe out there.